Okay, so now we're going to do the limits involving infinity. Okay, limits involving infinity. Okay, so the way we do these is very simple. I'm going to show you like the method. And then close on us again. Shoot. Okay. Okay, I think we are ready. Okay, so limits involving infinity. I'm going to show you the approach, and then I'll show you the shortcuts. Okay, so the approach goes as follows. When you're doing limits goes to infinity, so the rule to evaluate. Those limits. Okay, divide. It's very simple. It's one rule. That's it. Divide every term by the highest degree x in the denominator. Simplify when you divide, after you divide, and then evaluate limits or find the limit. Does it make sense what I'm saying? Okay, let's go to an example because it's just easier to understand it with an example. So here's what I'm saying. Look, it's very simple. So let's say we have the limit of x to the 4 minus, make sure x to the 4 or 3x to the 4 minus 5x squared plus 2 over 13x to the 4 minus 5x plus 7. Okay? As x goes to infinity. This only applies, these rules only applies to limits involving infinity, plus infinity or minus infinity. So look, what is the highest degree x in the denominator? Here. Denominator, not the numerator. X to the 4. So you see this x to the 4? You divide each one by x to the 4. So we're going to go and say this is the limit of 3x to the 4 over x to the 4. Each one gets divided by x to the 4 minus 5x squared over x to the 4 plus 2 over x to the 4 divided by 13x to the 4 over x to the 4. Here with me, minus 5x over x to the 4. I know it looks a lot, but it will simplify greatly now, like a lot, yeah? It's not hard, as x goes to infinity. Okay, now the next step is simplify each one. So we get the limit as x goes to infinity What's 3x to the 4 over x to the 4? Those go away. Yeah? And we get 3. On the second one, you get what's x squared over x to the 4? 5 over x squared, yeah? Because
yes,
x squared cancels out and you get x squared left. On the third one, nothing. And then in the denominator, x to the 4 and x to the 4 cross out. So you get 13 minus 5. Here, 1x goes away. So you get 5 over x cubed. You understand? Plus 7 over x to the 4. Okay, now plug in infinity. Evaluate the limit. So you get 3. Let's make it colorful. 3 minus 5 over infinity plus 2 over infinity over.
Infinity doesn't square or anything. It doesn't matter. It's infinity.
It'll still be
Keep
infinity.
being
Yeah,
infinity, right?
exactly. 5 over infinity plus 7 over infinity. What's 5 over infinity?
Infinity.
No, because you're dividing 5 over infinity. Think of it this way. How many times does infinity divide 5?
Never.
Never. 0. Or another way to say it, 5 divided by a very, very, very large number.
So this one's 0, that one's 0.
All of them. They're all zeros.
Now we end up with
3 over 13. So that's how you evaluate the limits going to infinity.
okay.
Now, you will encounter, let me now give you the shortcuts. Okay? So, the shortcuts. You will encounter 3 types of limits with this. You've got the ones where the degree in the numerator and the denominator, the highest degree is the same, like the one we just did. So this is one highest degree. So this is the first one. Degree x, same. And numerator and denominator. This is the one like we just did. So what do you do? Example. Okay. So this was case 1. We are discussing now. 3x squared minus 7x plus 1 over 4x squared minus 2. And then we are taking the limit as x goes to minus infinity. Look, you can just look at the highest degree x in the numerator and the denominator. What is it? It's x squared in both, yeah?
Mm-hmm.
So the answer will just be the coefficients of those x's. Like this.
Mm-hmm. Oh, okay.
That's it. 3 over 4. That's the shortcut.
What about all that other stuff?
Don't matter. Doesn't matter because at minus infinity, the x squared overtakes everything else. Those are as if they didn't exist. And I kind of showed it to you here. When you divide, they all go away. The only ones that survive are the ones that have the x to the 4. So this is a similar example. Okay. So you just get 3 over 4. Is that clear?
Yes.
Okay, so this is the answer. Now, the second case is highest degree x in denominator is bigger. Let's go to the example right away. What I'm saying is, if we're going to take the limit as x goes to infinity of x minus 3 over x squared, 3x squared minus 7. What do you think the answer is? So here, this is a case where the degree in the denominator square, the highest one, is more than the numerator.
Right.
0.
Oh, right, 0.
And if you think about this, it makes sense, because if x goes to infinity, here you're squaring infinity, so you're making a number that's super, super large, much larger than the one in the numerator.
And that one's never going to be able to divide into that other, into the bigger one, right?
And the answer will be 0. The third and last case is the other way around, when the top is bigger. Okay? Okay. Highest degree x in numerator larger than highest degree x in denominator. Okay, so let's go straight to the example. You know what I mean, yeah? It's like this flipped. So, example, what's the limit? I'll just take this and flip it. Of 3x squared minus 7 over x minus 3 as x goes to infinity. So the highest degree x in the numerator is x squared, the highest degree x in the denominator is x. So x squared is bigger than x. What do you think the answer is? Infinity. Because this guy will overtake him. And this guy will be, this guy will be super large, but compared to this one, it will be nothing.
Right.
So the answer will be...
This will go into this infinity times, right?
Yeah, exactly. This will go into infinity time. So you see the three cases?
Yes.
Summarize really quick. When they're the same, you just take the ratios of the numbers, whatever they are, 3 over 4. When the bottom is bigger, it's 0. When the top is bigger, it's infinity. And by the way, if you have to show work or do it from scratch and you apply, there's only one method with those involving infinity. If you just take the highest degree in the denominator and divide everything by that, and then evaluate the limit, you'll get the same thing. I'm just showing you the shortcut. Do you understand what I'm saying? On every single case here, I could have done that method and divided, like here, on 1, I could have divided by everything by x squared, and I will get 3 over 4. And here I can divide everywhere, every term by x squared, and I will get 0. And here I can divide, if I want to do this the longer way, I could have divided each one by x, and I will get infinity. So this summarizes the limits involving infinity. Any questions?
No, sir.
Okay, so